In this segment, we're going to talk about the absolute value parent function. We talked about absolute value earlier in the chapter. Absolute value is the distance a number is from 0 on the number line, and since absolute value represents a distance, distance can never be negative, so absolute value can't be negative. So for this one, what we will do is we will do an XY chart. We will plug some numbers in for x, just like we did for quadratics, and find the absolute value of those numbers, and that will form our parent function for the absolute value. Just like in a quadratic function, y equals x squared was our parent function, in an absolute value, y equals the absolute value of x is our parent function. Now, before, when we talked about quadratics, we said that the number in front was your a. That's still going to be the case. We said that if a is negative, it will flip it upside down. That still is going to happen with your absolute value function. We said that the number that is on the inside with the x will tell you whether to move the vertex right or left, opposite of what you would think. So if it's a minus, you move to the right. If it's got a plus, you move to the left. And then if you've got a number on the outside, then that number tells you whether to move up or down. Positive is up, minus is down. So that rule still holds true for the parent function of the absolute value. Anything on the inside tells you to move right or left, outside, up or down. The number in front kind of changes the slope of what your absolute value is going to look like. So if we're doing the parent function for the absolute value, we still need to choose 0, some positives, and some negatives. So what I'll do is I'll just choose -3, -2, -1, 0, 1, 2, and 3. We'll start with the same points and we'll go from there. So if I plug -3 in for x, absolute value of -3 is 3. Absolute value of -2 is 2. -1 gives you 1. 0 gives you 0. Absolute value of 1 is +1. There's where a lot of students mess up. They think that absolute value means opposite. It doesn't. It means it's going to be the positive of that number. It cannot be negative. So the absolute value of 1 is 1, not -1. Some students mess that up. If you plug 2 in, absolute value of 2 is 2. Absolute value of 3 is 3. So if we plug those onto the graph and form our ordered pairs, we've got -3, 3, -2, 2, -1, 1, 0, 0 is our vertex, 1, 1, 2, 2, 3, 3, and this function is going to continue that pattern all the way through. And if you notice, as I'm doing this, look at the slope of this side. You go up 1, right 1. So the slope here is 1. The slope here is -1. So you're going to have a slope on the right and the left, and those slopes are going to be opposites of each other. Notice if we fold this across the y-axis, it would be symmetrical. Looking at this, we know that a here was +1. That a value is going to be the slope of your right-hand side of your parabola. Now, if that were a -1, then it flips it and the right-hand side becomes negative on the bottom. Okay, so we'll talk about negatives. But this right here is your parent function of the absolute value graph. I have 3 more absolute value equations here. In the first one, I've got y equals negative absolute value of x. That negative in front means we're going to multiply whatever the absolute value of the x value is by -1. So that's understood to have a -1 in front of it. I'm going to choose some negatives and some positives and 0. And I tend to use these numbers unless there's some special case within the function that makes me want to try different numbers. And we'll talk about that when we get to some fractions. So if I plug -2 in for x, the absolute value of -2 is 2, and -1 times 2 is -2. Now, keep in mind, we are not saying the absolute value of -2 is negative. We're multiplying its absolute value by a negative. So the absolute value is positive, but when you multiply a positive number times a negative number, you get a negative number. So don't let that confuse you. Plug -1 in, -1, absolute value of -1 is 1, times -1 is -1, absolute value of 0 is 0, times -1 is 0, absolute value of 1 is 1, times -1 is -1, absolute value of 2 is 2, times -1 is -2. So there are my ordered pairs. Now, what did we say we thought the negative a would do to our function? Didn't we say it would flip it upside down? So let's see if that's what happens. -2, -2, -1, -1, 0, 0, 1, -1, 2, -2. And if you look at that, the absolute value function there with that -1 in front has been flipped upside down. And now remember, we said in the last portion of the video that whatever that a value was in front of the absolute value is probably going to be your slope of the right-hand side of the absolute value function when you graph it. So look at the right-hand side of this absolute value function, the one in blue here. The slope there is up 1, left 1, so -1, which is the value of your a. So if you know that the basic shape of an absolute value function is going to be a V shape if the a is positive, then you can tell what the slope is by looking at the number in front of the absolute value symbol, okay? If you know that if there's a negative in front, that just flips upside down, and so my slope of the right-hand side would now be negative, that would indicate it's just an upside down V, okay? And that would give you your absolute value. So I'm going to go ahead and label this, that's y equals negative absolute value of x. And you could do this in Desmos. Desmos will color code the different graphs for you if you don't want to do it by hand. But I do feel like it's important for you to understand where the ordered pairs are coming from. So still, we don't want to do everything on Desmos in our notes necessarily, because we do need to understand where the ordered pairs are being generated from and how to plug into an equation, because there are instances where Desmos might not be available, or they give you a graph of something and they're asking you to generate the equation. So if you can't go forwards, it's going to be impossible for you to go backwards in generating that equation. So very important that you understand this aspect. Now for this one, I'm still going to choose some positives and some negatives here. Looking at this one, there's a positive in front, so we know it's going to open up. It's a positive 1/2, so I'm thinking the slope of the right-hand side of the absolute value is probably going to be 1/2, but we'll see as we do these ordered pairs. So let's say, okay, if I have an odd number in here, then it's going to give me a fraction. I'm going to try to avoid fractions. So what I want to do is I want to plug even numbers in here, because when we multiply even numbers by 1/2, we'll get nice whole numbers, and that's what we want, or integers. And it makes integers are easier to graph, so that's what we'll do. So I'm going to start with -4, -2, 0, 2, and 4. If I plug -4 in, absolute value of -4 is 4 times 1/2 is 2. Absolute value of -2 is 2 times 1/2 is 1. Absolute value of 0 is 0 times 1/2 is 0. Absolute value of 2 is 2 times 1/2 is 1. Absolute value of 4 is 4 and times 1/2 is 2. Those are my ordered pairs. So I'm going to graph those. Left 4 up 2. Left 2 up 1. 0, 0 is still my vertex. Right 2 up 1. Right 4 up 2. And if I look at that, here's the right-hand side. Here's the left-hand side. And let's look at that slope. The slope of the right-hand side, starting at 0, 0, I go up 1, right 2. So in fact, my slope is the same as my a value on the right-hand side. And then understand, if I get the right-hand side, I can use symmetry to get the left-hand side, because I know this absolute value is going to be symmetrical about the vertical line that goes through the vertex, okay? So I can use symmetry. This is 4 from the vertex line, and 4 on the other side is my other point. So we can use symmetry if we don't want to do the XY chart every time. And one more thing I want to mention. 1/2. Think about the a values when we did quadratics. When we had 1/2, or when we had fractions between the -1 and 1, okay? Didn't we say that it was going to make the parabola wider? Well, look here. Here's our parent function. What happened with my parent function when we have a fraction? It became wider. So that is still going to be consistent with what we learned for parabolas or quadratics. So this one is y equals 1/2 absolute value of x. I'll just put that there so we don't get confused of which equation is which. So knowing that and thinking about your knowledge from quadratics, what would you predict the y equals 2 times the absolute value of x would be? Would it be narrow or would it be wide? Would it open up or would it open down? Okay, so think about those things. I'm going to say it's going to be narrow and it's going to open up. That is a whole number, so we're going to get all whole numbers. It doesn't matter what I choose, so I'm going to do my -2, -1, 0, 1, and 2 again. So I'm going to put these numbers up real quick. If I plug in 2, I get 4. 1 gives me 2, or -1 gives me 2. 0 gives me 0. 1 gives me 2. 2 gives me 4. And then I'm going to graph those. So -2, 4, -1, 2, 0, 0, 1, 2, 2, 4, and if I graph that, I have my absolute value function right there. Let's look at the slope. It does open up because that was positive. Look at the slope of the right-hand side. We go up 2, right 1. Slope of the right-hand side is 2. So, works out pretty nice. We've talked about the parent function. I'll go ahead and label this. The parent function is the one in black. The dilations of that parent function are here. This one, actually, this is a reflection. Okay? These two, the red and the green, are dilations. Right? Dilations are when it gets wider or more narrow. I still have the parent function up here. Now we're going to talk about what happens if we have a translation or we have some numbers on the inside and the outside. Now, looking at this one, looks like my a value is 1, so that means the slope of the right-hand side is going to be +1. Instead of though my vertex being at 0, 0, this -3, -4 is going to change it. Now think about parabolas or quadratics, and when we did those, if it was a negative on the inside, what did that tell us to do? If there was a negative on the outside, what did that tell us to do? You think about that, and we're just going to choose some points, and we're going to do the math and see what happens. Okay, so I'm going to choose some negatives, some positives. Now, sometimes with these, as you're choosing numbers, you may only get one side of the absolute value graph. If that happens, what you have to do is just choose more numbers until you see where that V is going to form. Once you see where that's going to form, then you can use symmetry to find the rest of it. Okay? So looking at this, if I plug -2 in, -2 minus 3 is -5. Absolute value -5 is 5. 5 minus 4 is 1. -1 minus 3 is -4. Absolute value -4 is 4. 4 minus 4 is 0. 0 minus 3 is -3. Absolute value -3 is 3. 3 minus 4 is -1. 1 minus 3 is -2. Absolute value -2 is 2. 2 minus 4 is -2. 2 minus 3 is -1. Absolute value -1 is 1. 1 minus 4 is -3. I'm going to graph those. So I've got -2, 1, -1, 0, 0, -1, 1, -2, 2, -3. Okay, I do not yet see where this thing is going to be, but I do know that since this is positive, it's going to be going up, okay? So since I know that this is my negative side, I know I need to choose more positive numbers to the right of 2 to see where it starts going up. So let's do that. I'm going to choose just 2 more and let's see what happens. 3 and 4. So let's plug those new two numbers in. So 3 minus 3 is 0. Absolute value is 0, 0. 0 minus 4 is -4. 4 minus 3 is 1. Absolute value of 1 is 1. 1 minus 4 is -3. And then we'll graph those. So let's see. 3, -4. still going downward. 4, -3. Okay, look at that. That started to go back up. So now, this must be the axis of symmetry. So we should be able to use symmetry to get the other points that we need to see what this graph looks like. Okay, so it goes something like that. I probably should use a ruler, but honestly, we're using Desmos most of the time for something like this, so we're not going to have to graph these by hand usually. It's just good for you to see where this information comes from. Okay, so there's my absolute value. Now let's talk about parabolas and see if this is consistent. First of all, talking about parent functions of absolute value, the a value here is 1, so that means the right-hand side of our absolute value function should be 1, or the slope should be 1. So look at the right-hand side. At the vertex, we go up 1, right 1 to get to the next point. Up 1, right 1, up 1, right 1. So the slope of that is 1. That's consistent with what we learned before. Okay, now, my vertex of the parent function usually starts at 0, 0. But here, I have a -3 on the inside. When it's a minus on the inside, that tells us to move opposite of what we would think. So we're moving right 3. And then on the outside, we have a -4, which tells us to move down 4. So opposite of what you would think, same as what you would think. So right 3, down 4, from our original vertex 0, 0. Right 3, down 4. Yes, that is consistent with what we learned for quadratics. So that property still holds true. In fact, anytime you have a translation like this with an equation, the inside number will tell you to move right or left, the outside up or down, depending on the sign. Okay? So still consistent. Now, knowing that, look at what we've got here. Let's try to graph that without doing anything with an XY chart. Now, if you get stuck, you can always do an XY chart or add it in there. But we're going to try to do this one without it. Now, let's just think about this. Our vertex. To find where our vertex would be, we know it's going to move, it's a +1, so left 1, and then a +2, up 2. So from the original origin, 0, 0, we're going to move left 1 and up 2. So it's right here. That's where my vertex will be. This is a -2, so that means it's going to open down. So that's our vertex. It's going to open down. And then what's the slope of the right-hand side going to be? It's going to be -2. So from this point, I'm going to go down to right 1. From that point, down to right 1. And then, so this is going to be my right-hand side, the slope of -2. And then I can use symmetry. Here's my axis of symmetry. So I could use symmetry to get the other side. Or another thing I can do with that is if I understand the slope of the right-hand side is -2, the slope of the left-hand side is going to be opposite, +2. And so here is my absolute value function right there. So that's the red one. So now, see if you can do the green one. Y equals 1/2 x, or 1/2 the absolute value of x, plus 3. Pause the video, see if you can do that real quick. I know you have Desmos, but see if you can just draw a little makeshift graph and see if you can figure out where it would be. Then put it on Desmos and check yourself. Okay, so for this one, my vertex, there is nothing inside with the x, so that means it stays at 0. And then it's going to go up 3. So I'm not going to move right or left anywhere, but I am going to go up 3 for my new vertex. Then I know the right-hand side is a 1/2, so the slope of the right-hand side is a +1/2. It will make this one a little bit fatter, a little bit wider than the parent function. And there is that absolute value graph.